Alright, so today we are going to look at some different ways to solve quadratic equations. First couple will be sort of review of something we saw in the last chapter, and then we'll move into something new. So first of all, we are going to factor this equation down. We basically say what multiplies to negative 24 and adds up to 5, and we have to solve each bracket separately, which is why we get negative 8 and positive 3. Those represent the x-intercepts of that parabola. The second one over here in blue, notice we can't factor this, so instead we're going to try to complete the square. We add a 16 to complete it, minus a 16 to balance it, and now we've got negative 19. We move it to the other side and we're able to square root both sides, and we end up with an answer of negative 4 plus or minus root 19, which actually represents two different answers, right? The first answer is when we subtract root 19, the second answer is when we add root 19. We could, on a calculator, type these in and get some approximate decimal answers. So that'd be about negative 8.36, and this one would be about, let's see, 0.36. And again, those represent the two x-intercepts, or the roots, of the equation. And notice the difference between an exact and an approximate answer. So that was factoring, and then completing the square, so square rooting both sides, and both have the same goal. You're ultimately finding x-intercepts of quadratic functions. Now, the focus in this chapter, however, is more so on quadratic equations, so we sort of get away from the graph sometimes, and we start to use a new tool. So in this case, we rearrange this, we set it to 0, try to factor it, and we realize nothing multiplies to negative 1s and adds up to 6, which means it doesn't actually factor. So our new tool is going to be to use the quadratic formula instead. So we looked at this before, but basically if you have 0 equals ax squared plus bx plus c, through completing the square, you can solve for x and realize that that big looking equation there, negative b plus or minus square root b squared minus 4ac over 2a, is called the quadratic formula, and that will solve for x. So the key is to figure out what your values of a, b, and c are, and then plug them into your equation. Usually it's easiest to do the discriminant part first. So in this case, 6 squared minus 4 times 1 times negative 1. It's actually 36 minus negative 4 plus 4, which is 40. And we sometimes want to split that up into sort of two chunks there, because they're both being divided by 2. And the last thing is to simplify the square root 40 down into 2 root 10. So we clean up our answer a little bit. We get negative 3 plus or minus root 10. And that negative 3 actually represents the axis of symmetry, and then we can plus or minus from that symmetry line to get to the two roots. And note that those were exact answers in radical form. So the next one is similar, but the numbers are a little bit bigger. So we'll have 9x squared plus 4x minus 16. It's equal to 0 already. So we just have to identify a, b, and c, and now we will plug them into the quadratic formula. And again, we can see we're minusing a negative number, so that's going to turn into 16 plus some number. We'll figure out whatever 4 times 9 times 16 is. And I'm going to do this two different ways. First, I'm going to literally type in what the discriminant is, figure out that it's 592, or if I just found out what 4 times 9 times 16 is, which is 576, add that, that's going to make 592 under our square root. So again, we want to simplify this most likely. We want to figure out, can we take any perfect square factors out of 592? Now there's various ways to approach this. One way is to just kind of brute method start dividing 592 by different perfect squares until we find one that works. 4 seems to work, 9 works. Now I might as well choose the biggest one possible. It looks like 16 also works. So let's stop there, and we'll choose 16 times 37 is 592. The reason we do that is that we can actually square root 16, pull it out as a 4, and get 4 root 37 instead of square root 592. This works nicely because now we can reduce these fractions down a little bit, from 4 over 18 instead down to 2, or negative 2 over 9. And those answers say approximate. Those should actually be equal signs right there. Those are exact answers in radical form. If we did want to get approximate answers, we could type it into our calculator, or maybe something like Wolfram alpha. And I can sketch out the parabola and see what it looks like. And if I click approximate form on the bottom, it will change my answers into decimal form. And there's those squiggly equal signs that I accidentally used before. So I'll paste those in. Those are the same two numbers. And let's paste the parabola in there. We should figure out which one is which. So notice when you add to root 37, that takes you over to the right. So that bottom answer, the positive 1.12, that's the first root. The second root is when you subtract, that represents going over to the left. And notice that roots from Wolfram Alpha are actually x-intercepts. They mean the same thing. Another neat thing is that the axis of symmetry there is that -2/9. So that sort of tells us where our middle point is. And we can see we're going to the right and to the left to get the two x-intercepts. Hopefully you found that helpful. Thank you.